We had our discussion about covalent bond and ionic bond. And basically, compounds are divided into two ionic compounds and covalent compounds. And we may expect almost all compounds are 100% ionic and 100% covalent. But it is observed that many of the bonds are neither purely ionic nor covalent. And we know ionic bond is formed by the transfer of electrons from one atom to another atom, resulting the formation of cations and anions, while covalent bond is formed by the sharing of electrons between two atoms. But it was observed that in many of the ionic compounds, there occurs a sharing of electrons, and in many of the covalent compounds, there is a partial polarization of charges. Hence, ionic compounds could have covalent character and covalent compounds show ionic character. We have to discuss about the covalent character present in ionic compounds or ionic bonds. Now we discuss about the Phagens rule. Basically, Phagens rule predicts the covalent character in an ionic compound. We know an ionic compound should be represented as M plus and X minus, and we may expect this is 100% electrostatic force of attraction operating between the cation and anion. But on observation, many of the ionic compound shows certain covalent character. And Phagen came up with some explanation for this observed partial covalent character in an ionic bond. And it is summarized as Phagens rule. So we have to discuss about the Phagens rule which predict the partial covalent character in ionic bond. So as per Phagen, if two oppositively charged ions, that means cations or anions, are brought together, the nature of the bond between them depends upon the effect of one ion to another. That means if I bring a positively charged cation and a negatively charged anion towards closer, the attractive force between them, that is the electrostatic force of attraction between them, will be predicted or depend on the effect of influence of one ion to another. And studying this, he proposed the concept of partial covalent character in ionic bond. If we take two ions M plus and X minus, and when they approach each other, naturally the positively charged ion attract the negative charge on the anion. Okay, that means we know cations are smaller in size while anions are greater in size than the corresponding atom. Cations are always smaller than the corresponding atom, while anions are greater than the corresponding atom. Thus, the positively charged cation attract the negatively charged electrons present on the outermost shell of the anion. Simultaneously, it repels the positive charge on the nucleus of X minus. X minus is an ion which is having a positive nucleus and an excess negative charge. So the cation attracts or deform the negatively charged accumulation around the anion. Hence, there occurs a polarization or distortion. If the polarization by one ion to another is very small, predominantly the compound becomes ionic. You got it? If the polarization is very large, there exists a covalent character. That means sharing of electrons occurs. This is the basic concept of Phagens rule. That means a positively charged ion induces polarization to the electron cloud of the negatively charged anion, result in the formation of a deformed ionic density around the anion. This is called the polarization. Take down. Using this picture, we could easily explain the polarization concept. See, this is a undistorted isolated anion. This anion remains isolated. And to this isolated anion, a positively charged cation is approaching. So, a positively charged cation and a negatively charged anions establish an electrostatic force of attraction, result in the formation of an ionic bond. Now see here, as I told you earlier, this positively charged ion attracts the negative electron density around it towards its side, towards the side of the cation. As a result, the uniformly distributed negative charge now gets polarized towards the positively charged ion. That means there exists a sharing of electron between the anion and cation. And that covalent character is due to the polarization of the anion by the cation. That means we could say the anion get polarized. Listen carefully. The anion get polarized while the cation induced polarization to the anion. You got it? See here. Two cases here. In the case of A, we are imagining ideal pairs, positive and negatively charged ions. Uniformly, their charges are distributed. Now undergoing polarization. As a result polarization, the electron density is shared between two nucleus. That means from a ionic concept, the molecule is moving towards a covalent concept. This is polarization. Thus, The power of an ion, usually cation, to distort the other ion, that is the anion, is called the polarization power. And the tendency of the anion to get polarized is called the polarizability. So, two concepts has come from the polarization, that is polarization power and polarizability. Who is having polarization power? The cation is having polarization power. Who undergo polarization? The anion undergo polarization. Usually, the reverse type of polarization is negligible. That means the polarization power of anion is negligible, while the polarization power of cation is very high. Greater the polarization power or polarizability, greater the tendency to become covalent bond. This is the basic concept of Phajan's rule. When polarization increases or when polarization power of cation increases, the polarizability of anion increases and hence the ionic character decreases and the covalent character increases. Very, very important. Take down. Scientist Phajan studied clearly about the polarization power and polarizability, and he studied about the covalent character in ionic compounds, and this is summarized as Phajan's rule. So in Phajan's rule, the first concept is that small positive ion or cation creates greater polarization and hence greater covalent character. So if the cation is very small, the polarizing power of that ion is very high. As a result, the covalent character will be greater. So the first concept is smaller the positive ion, greater the covalent character. Second concept is about anion. When anion becomes larger, greater, it easily undergoes polarization or it easily get polarized. Easily get polarized means the electrons will be easily shared between positive and negatively charged ions. So, second concept is that greater the size of the anion or negatively charged ion, greater is the polarizability and hence greater is the covalent character. Carefully you take down. I repeat, smaller the size of the positive ion or cation, greater it is its polarizing power. When polarizing power is greater, it becomes more covalent. Second concept is the size of the anion. Greater the size of the anion, it easily undergoes polarization or susceptible to be polarized. Hence, greater the covalent character. The third concept is regarding charge. Greater the charge on the ion, if the positive charged ion or cation is having greater positive charge, it is more strong. That means it have more polarizing power. Similarly, if greater is the charge on the negative ion. Greater is the charge on the negative ion, that is the anion. It easily undergoes polarization and hence become more covalent. So we discussed about the size. Now we discussed about the charge on the ions, cations or anions. The third concept is regarding the electronic configuration. I have two ions. They have same size, same charge. But the difference between these two ions is that one is having a pseudo noble gas configuration. That means 18 electrons in the outermost shell, while other is having a noble gas configuration, that is 8 electrons in their outermost shell. So we are considering a fourth case. Here two ions, same size, same charge. For example, you take two positive ions, both have same charge, same size, but there is difference in configuration. Hence, the pseudo noble gas configuration will be more polarizing. That means the ion, the cation with a pseudo noble configuration is more polarizing than noble gas configuration. So these are the four important concepts of Phagens rule. First one regarding the size, second regarding the size of the anion, third regarding the charge of the cation and anion, and final regarding the electronic configuration, that is pseudo noble gas configuration and noble gas configuration. We will explain with examples. Take down. Take the example LiCl and KCl. We know lithium, sodium, potassium, rubidium, cesium. All these elements belongs to the first group. Lithium, sodium, potassium, rubidium and cesium. So here lithium and potassium. And we know all first group elements only form positive ion, Li plus and K plus. They are combining with the chlorine, Cl minus. Here also Cl minus. That means the anion is same, Cl minus. The charge of the anion is same. Cation is different, but the charge is same. But LiCl is more covalent than KCl. What may be the reason? Lithium chloride is more covalent than potassium chloride. The reason is very simple. When we move from top to bottom, the size decreases. Li plus is having a smaller size, while K plus is having a greater size. So, smaller the size of the Li plus, greater the polarization power. Greater the polarization power. Hence, it easily polarizes Cl minus, while K plus the size is greater. Hence, less is their polarizing power. Hence, it cannot polarize Cl minus as lithium does. So, we could say the answer is the size of lithium ion and potassium ion. Greater the size of the ion, smaller the polarization and hence smaller the covalent character. See here. This is the pictorial representation. See, here fully ionic. So polarization occurs. As a result, sharing of electrons occurs. That means from ionic, the covalent character is gradually increasing. Same thing is here. This is the lithium. This is Cl minus. Lithium is having a smaller size. It attracts the negative electrons of Cl minus. Hence, it becomes easily polarized so that it becomes covalent. You got it? Take down, very important. Take down the order of covalency. Lithium chloride is more covalent while cesium chloride is less covalent. See this question? Get me the answer. The melting point of lithium fluoride is 870 degree while that of lithium chloride is only 613. Why? Write down the answer, then we will discuss. Are you sleeping or writing the answer? See here, lithium fluoride and lithium chloride. When we consider lithium fluoride and lithium chloride, both the cation is same, lithium, Li plus in LiF and Li plus in LiCl. But the size of anion is changing. One is F minus, another is Cl minus. F minus and Cl minus. So what happened? The size of F minus is small while the size of Cl minus is greater. So the size of the anion is greater in case of LiCl. So what will happen? The Cl minus will easily get polarized. Easily get polarized. That means LiF becomes a strong ionic bond while LiCl becomes a strong covalent bond. We know the melting points of ionic compounds are greater than covalent compounds. The melting point of ionic compounds are greater than covalent compounds. So, LiF is more ionic while LiCl is less ionic. Or we could say LiCl is more covalent while LiF is more ionic due to the size of fluorine and Cl. That is why the melting point is higher for LiF. Take down the answer. See here the melting points are given. You just check. When we move from fluorine to chlorine to bromine to iodine, the size is increasing. As a result, the covalent character increases from LiF to Lia. My dear students, don't get confused. Slowly you think you get the answer. Moving from fluorine to chlorine to bromine to iodine, the size of the anion increases. When the size of the anion increases, naturally the polarization increases. When polarization increases, covalent character increases. When covalent character increases, melting point decreases. See that connection? Take down. Check this question. CuCl, that is copper chloride, is more covalent than NaCl, even though the size and charge are same. Write down the answer. Think and write down the answer. See here, the anion present in both the compound is Cl minus. We know anions are having same size and same charge here. Cl minus, Cl minus. Same size, same charge. Cu plus 1 and Na plus 1. Same charge, same size. But CuCl is more covalent. Why? The only reason is that Cu has a pseudo noble gas configuration, while sodium chloride is having a noble gas configuration. So pseudo noble gas configuration get easily polarized. That means they have greater covalent character, while noble gas configuration have less covalent character. You check the answers. Same question will come. Ag, silver, AgCl and potassium chloride. Gold chloride and rubidium chloride. Gold and rubidium having same size. Silver and potassium is having same size. Copper and sodium is having same size. But the only difference between copper, sodium, silver, potassium and Au, gold, rubidium is copper, silver and gold have pseudo noble gas configuration, that is NS2, NP6, N-1, D10 configuration, while sodium, potassium and rubidium have noble gas configuration. Got it? Take down. See the next question. Fe2 plus and Fe3 plus. I have Fe2 plus and Fe3 plus. One is plus 2 and one is plus 3. So what happens? Which will be more covalent? Tell me. Fe2 plus and Fe3 plus. Both have different charge but size almost same. So FeCl3 is having more covalent character. Why? Because greater the positive charge, greater the charge on the cation, greater its polarizing power. That means it easily polarizes the anion, hence more covalent. Take down the question. Very important. You take down this question, you read the questions continuously, just check about Phagens rule and find out the answer. Similarly, a large number of questions are there. See another question. Covalent character of group 2 metals decreases from top to bottom along the group. What are group 2 elements? Beryllium, magnesium, calcium, strontium barium. Check again. Beryllium, magnesium, calcium, strontium and barium. When they move from top to bottom, the size increases. See here? The size increases. So, covalent property increases. Be2 plus, high polarizing power, smaller size, greater their polarizing power. That means they easily polarize Cl minus ions than Ba2 plus. For Ba plus 2 plus, barium 2 plus, the size is greater. So polarizing power is small. That means the covalent character decreases. While for beryllium, they have small size, greater the polarization. Don't get confused. Greater the polarization, greater the covalent character. See here, covalent character of different calcium halides increases from F minus to I minus. Why? Size increases. F minus, Cl minus, Br minus, I minus. I minus is having maximum size. Greater the size of the anion. I minus, F minus are anions. So greater the size of the anion, easily get polarized. Hence, greater the covalent character. So a question comes. BF2. See, beryllium fluoride. BF2 and BaF2. Which is more covalent? Another question comes. BeI and BeF. BeI and BeF, or better BaF and BeI2, BeF2. Dihalides now. So beryllium difluoride, beryllium diiodide, BeF2 and BeI2, which is more covalent. Similarly, BaF2, barium fluoride, and BaI2, barium iodide, which is more covalent. So just think and answer. FAJAN give 4 consideration: size of cation, size of anion, charge of cation, charge of anion, and pseudo noble gas configuration and noble gas configuration. We should think which concept has to work at what place. You got it? Take down. If you are taking the screenshot, I am very sure you are not answering the question properly. You cannot answer the question. You take it down, think and answer. See another question. AlCl3, AlCl3, that Cl3 is down, Cl3 is more covalent than MgCl2, and MgCl2 is more covalent than NaCl. What may be the reason? You just think. The size of Al, the size of Mg, size of Na are same. The size of Al3 plus, the size of Mg2 plus, and the size of Na plus are same. But what is the difference? Al plus 3 positive charge for aluminium. For magnesium, there is only 2 positive charge. And while for sodium, there is only 1 positive charge. So, it is the charge that depends. So, greater the charge, greater the polarizing power, greater the covalent character. That concept you should not forget. Greater the charge of the cation, greater the polarizing power, greater the covalent character. See here. Na plus, Mg plus, Al plus. So the covalent character increases. Got it? Okay. Now I am going to give you assignment questions. Write down the questions. Don't send the answer. Next class, I will call you one by one. Next week, I am not going to take you class. I am only going to discuss these questions. That means you are going to give me the answers of the questions. Okay? Are you ready? Yes, I know you are very strong. Take down the questions. These are the questions. Take down. The melting point of AgCl is 455 while that of KCl 766. Explain. Calcium iodide and calcium fluoride. Take down the questions. I am not reading. You have enough time. Take down the questions. Find out the answer. I will call some in the next class. Not only this question. Some questions related to Phages rule. I hope you have finished the questions. So thank you, my dear students. Answer the questions. Next class, be ready to explain the answers. Thank you. Thank you very much.